4, I'm going to go over the evens because I asked you to do the odds. So I'll go over the ones I did not ask you to do. So again, you're just doing the odds on the left. So Z is the centroid. So we know that we have medians. So all of these sides are going to be bisected. They are midpoints. These are the midpoints. X, Y, and W are all midpoints. I want to find, or we're given some information here. So WZ is 4. WZ is 4. So we know we have a 2/3 formula here. So if this is 4, we know that the other leg is going to be twice as long. That makes ZM 8. We know that Zn is 14. Zn is 14. So that this side will be half of this length. So XZ is 7. Now we want to find WM, which is the full length. 8 plus 4 is 12. XN, so I want to find the full leg, 21. Now we want to find LZ. To find LZ, I need to know this side. Oh, we're given it. ZY. This is 10. So to find LZ, we will double this to get 20, which comes out to 20. Okay, number 4. If M is the centroid of this triangle, GHI, HL is 45. So the whole length here is 45. JI is 63, and KJ is 60. So we're given the full lengths. So we kind of have to go reverse. I need to find what 1/3 of each of these is. So 45 divided by 3, 15. So a third is 15. So I know that the short side of HL will be 15. The long side will be double that, which is 30. So 15 plus 30 is 45. I divided it into thirds. Okay, JI is 63. So I take 63, divide it by 3. 63 divided by 3 is 21. So I know that the short side of JI is 21. Multiply this by 2, I get 42. That makes the long side 42. Okay, KG is 60. 60 divided by 3 is 20. So I know the short side is 20. Long side will be 40. So if you notice, 20 plus 40 is 60. It should all add up. So I basically wrote the answers out here. I won't be filling this in. Okay, if Z is the centroid of the large triangle, WR is 87. So the long side is 87. For the long piece, divide that by 3, get 29. So I know the short side is 29. 29 times 2 is 58. Long side is 58. So ZR 29. WZ 58. SY is 39. Did I say that right? Yep. SY is 39. So I know that SW is also 39. Because S is the midpoint of YW. WY, add 39 and 39 together, 78. Now I need ZT. So am I given YT? I am. YT is 48. Divide that by 3. 16. So I know the short side is 16. ZT 16. Now I want YZ. So if I double 16, I get 32. Long side's 32. Okay, turn the page over. Classify each of the centers as circumcenter, incenter, centroid, or orthocenter. Okay. So here I notice that it is going from a vertice to a midpoint, vertice to a midpoint, vertice to a midpoint. So vertice to middle, that is going to be a median. So these are all medians. And medians meet at what is called the centroid. Okay. So here I have a couple options. I know that these are perpendicular because of the 90-degree marks. But it's not cutting the side in half, so it's not a perpendicular bisector. So if you look back through your notes, the first thing you'll notice when you get perpendicular sides, there's only two of them that deal with perpendicular sides. First one is perpendicular bisectors. The second one is altitudes. So these are all altitudes. Altitudes will meet at, that's the first one, orthocenters. Number 11 looks very similar to number 7. We have midpoints all the way around. It's going from vertex to midpoint, vertex to midpoint. So these are all medians. Medians meet, create a centroid. Okay, next one, 13. Now we're kind of, I wouldn't say this is hidden, but there's pieces of information that we're not given on this. Now, we're going off of the note that the center, where they're all meeting, from that point to each vertice, or vertex, I keep saying vertex, vertex is equidistant. They're all congruent. If you look back to your notes, that is perpendicular bisectors. So these are all perpendicular bisectors off of each side. So for example, this would be a perpendicular bisector. This would be a perpendicular bisector. And this would be a perpendicular bisector. They're all going to meet right here. Perpendicular bisectors meet at circumcenters. I'm going to go over the right side. Again, I didn't require you to do it, but it's always nice to know. So, angle marks, angle marks, angle marks. These are all angle bisectors. Angle bisectors meet at incenters. Again, 90-degree marks. So we have two options. We have altitudes or perpendicular bisectors. This does not go to a vertice, so this is perpendicular bisectors off of each corner. Those meet at circumcenters. Now, this is not a perpendicular bisector. This is not showing that each side is congruent to each side like we had previously on this one. This is showing that for this point, each side is equal distance apart. So if we look back to our notes, these are all created from angle bisectors. Angle bisectors meet at an incenter. So 90-degree marks. So we're initially thinking perpendicular or altitudes. These go through all vertices. Each vertice is touched. So those are altitudes. Oh man. Altitudes meet at orthocenters. And that's it.